Page 523, number 59. Solve the system of equations. Well, right away I'm going to write this as a matrix. So let's put these coefficients in here. Negative 1, 1, negative 1, and negative 14. Let's go with 2, negative 1, 1, and 21, and 3, 2, 1, and 19. And we want to try to write this in reduced row echelon form, which means we want to try to get 1s across this diagonal, 0s in all the other spots. If we do that, these three values here will be the solutions for x, y, and z. Well, the first thing I want to try to do is get a 1 in this upper left spot. If I simply change the signs of each of these, now I've got a 1 in that upper left-hand spot. Okay, that's a good thing. All right, now I want to try to change my second and third equations to get 0s in the first column. So if I were to multiply this top equation by negative 2 and add it to the second row, that'll give me a 0 in this first spot. Likewise, I'm going to try to do two steps at once here. I'm going to multiply this top equation by negative 3 and add that to the bottom row, and that'll give me a 0 in this spot. So let's do both of those steps at once. So my top row is going to stay the same. 1, negative 1, 1, and 14. If I multiply the top row by 2, add it to this, excuse me, by negative 2, add it to the second row, I'll get negative 2 plus 2 is 0. 2 plus negative 1 is 1. Negative 2 plus 1 is negative 1. And let's see here, negative 28 plus 21 is negative 7. Doing the same thing to the bottom row, I'll multiply the top row by negative 3, add it to the bottom row. Negative 3 plus 3 is 0. 3 plus 2 is 5. Negative 3 plus 1 is negative 2. And let's see here, negative 3 times 14 is negative 42. Plus 19 is negative 23. Okay, now I've got a 1 here, 0's down the first column. Next I want to try to get a 0 in this spot. And I can do that by multiplying the second row by negative 5 and adding that to the bottom row. Okay, so let's do that. Notice the top row is going to stay the same. The second row is going to stay the same. The bottom row is going to change. So first column won't change at all. 1 times negative 5 is negative 5, plus 5 is 0. Negative 1 times negative 5 is 5, plus negative 2 is 3. And negative 7 times negative 5 is 35, plus 23 is 12. Now, I've got a 1 in the upper left corner, 0's in this lower left triangle, 1's across the diagonal except for this spot right here. So let's divide that bottom row by 3. That'll give me 1, negative 1, 1, 14, 0, 1, negative 1, negative 7, and 0, 0, 1, and 4. Now, we are over halfway done. Now I've got to work backwards to try to get 0's in these spots right here. Well, let's take two steps at once. First of all, if I add that bottom row to the middle row, I'll get a 0 in this spot. Likewise, if I take that bottom row times negative 1 and then add it to the top row, I'll get a 0 in this spot here. So let's take care of that. And I'm going to bring my work up here. So my bottom row now is not going to change. 0, 0, 1, and 4. My middle row, if I add the bottom to the middle row, I will start with 0. 0 plus 1 is 1. 1 plus negative 1 is 0. And 4 plus negative 7 is negative 3. Now let's multiply the bottom row by negative 1, add it to the top row. So it won't change the first or second numbers. 1 times negative 1 is negative 1, plus 1 is 0. 4 times negative 1 is negative 4, plus 14 is 10. Okay, we are so close to being done. One more step should do it. Last thing I need is a 0 in this spot right here. And I can get that by adding the middle row to the top row. So when I do that, my bottom row is going to stay as is. My middle row is going to stay as is. And my new top row is going to become 1, 0, 0, and 7. So we are done with our work. Our three solutions, x, y, and z, are equal to 7, -3, and 4. Now we can check that by plugging it in for x, y, and z, and we should do that. I'm going to let my calculator do the work. So I'm going to plug 7 in place of x, -3 in place of y, and 4 in place of z. So that'll give me -7 plus -3 minus 4. When I press enter, yes, that equals -14. Let's do it for the second equation. 2 times 7 minus -3 plus 4. That gives me 21. Now let's do that for the third equation. 3 times 7 plus 2 times -3 plus 4 equals 19. So since plugging 7, -3, and 4 works for all these equations, it is the one solution for this system of equations.